Good afternoon. Welcome to the CREDC seminar series. My name is Klara Našted. I am professor in the Computer Science Department as well as in the Information Trust Institute and also director of Coordinated Science Laboratory. It is my great pleasure to welcome a speaker today for our CREDC seminar, Al Rivero. And I want to introduce him briefly before he starts his talk. Al Rivero is the president of A&G Consulting. It is a firm that specializes in helping clients develop strategic technology and growth plans. This particular firm also provides development of long-term 3 to 5 year strategic technology plans to ensure reliable and secure migration of technology. Al Rivero also worked with development companies to ensure alignment with the industry expectation from platform use. Al has more than 30 years experience in the energy industry. He was holding various positions ranging from staff engineer, project manager, operation management, technology management, to managing Chevron's regulatory strategy group, focusing on developing CVX-wide strategy for addressing energy-related regulatory issue and assisting key stakeholders with assuring compliance with regulatory requirements. He also has extensive experience with IT and OT integration, SAP, JDE One World, and he also worked on various Honeywell and Foxborough DCS systems installations in chemical plants and refineries. Al has a bachelor degree of science in electrical engineering from Cal State Fullerton and a Bachelor of Science degree in computational mathematics from the University of California, Irvine. He also co-authored many papers on critical infrastructure protections for API, AGA, DOE, and has worked with DOE and DHS on critical infrastructure protection planning. He also was a great collaborator that we are currently working on in the CREDC project, so I really appreciate him coming and talking to us about critical infrastructure. And he will be talking oil and gas pipeline transmission infrastructure, cybersecurity, and resiliency. Please.
So what I'm going to do today is I have a brief agenda. I'm going to spend about 5 minutes doing a review of oil and gas transportation in North America, kind of go through the network layers in the different aspects, because oil and gas transportation is fairly flat across the board. Most companies tend to do it the same way. And then I'm going to take a little different take and go through the basis for design and why people do some of the things they do in support of resiliency in the regulatory environment that they sit in. And that'll be the closeout, and hopefully around 3:45 or so, we'll have time for Q&A. So this is a fairly generic pipeline infrastructure. The flow starts on your left, flows through the right. You have intermediate deliveries and takeoffs of the product. This can be a 25-mile pipeline. It could be a 1,000-mile pipeline. They're fairly consistent. They have consistent things. Pump stations, compressor stations, delivery and receipts. On the liquid side, they'll have tanks. On the gas side, they'll have spheres or underground storage. They all rely on similar components. They have PLCs, sensors at the local operations level. They have communication, and they have typically an IT infrastructure around the SCADA. They rely on WANs and different things. So what I'm going to do is break this picture into two main components to show the network layers, show the different components that are in place, and then we'll go into the design. I feel that this is important to give you some background on the whole architecture. So if you look at the top left-hand corner of the paragraph, That's kind of the typical SCADA system. In most cases, it's a fully redundant system at the main control center with a backup system at another location. The backup system can be a single stream system, or in a lot of the larger operators, they'll do redundant backup as well. But typically, it is at a remote location, typically not identified within the company. Most companies keep their pipeline operating center nondescript. They don't really want most people to know where their operating control centers are, especially their backup control center. Most operators exercise their backup facility a couple times a year. It's actually regulated that they exercise their backup control center. So the Department of Transportation under PHMSA actually determines the basis for design and how often. So this is an industry that is pretty heavily regulated, maybe not as much as the electric industry with NERC, but it's also pretty heavily regulated by DOT, and also in some jurisdictions, state of California, Texas, there's independent state agencies that also oversee the operation and may have more stringent codes than they do as well. The other thing that's interesting about this industry is there's industry best practices that have been put together by API, AGA, INGA, and other organizations that in some cases have been referenced in the Federal Register, which essentially become law. So leak detection is one of those documents, cybersecurity, control room management. They get referenced in the Federal Register as a recommended best practices, so at that point they have to all abide by the standard. When you look at this picture, it's not that different than other systems. You have servers, you have OSs, routers, switches, all the different components until you get down to the lower level when then now you start seeing PLCs, you start seeing I/O servers, little HMIs, operator interface, local historians, and those kind of components start playing in. When you look at the SCADA system, operators rely a lot on current off-the-shelf technology. So there's two primary OSs. There's a camp that uses Linux and a camp that uses the Microsoft platform. And it's kind of religion. You either are all in with Linux or all in with Microsoft. The two just are, that's how they are. The one thing that they do very well is the SCADA system is typically N-2 or N-3 from the edge devices. So the concept of peeling back the onion to get to the core of the onion for the SCADA system is definitely in play in the oil and gas transportation sector. Most clients, most operators will have a SCADA system deep within the footprint of their architecture, typically separated by a DMZ into the business system. And in a lot of cases, if it's an integrated oil and gas company, the pipeline operation becomes a separate environment for their LAN, and their pipeline control center is deep within that LAN. So there's a lot of segregation, and we'll talk about potential scenarios at the very end for how someone may get into the SCADA system when we go into that. But it's definitely multiple layers within the system. In a lot of cases, they'll have their own server to gain access for maintenance and services. And in most of the systems, third-party connections are typically not allowed. They're allowed if they're plugged in or turned on. So if the manufacturer of the SCADA system needs to access the control system, a lot of times that direct connection is not allowed. They have to request it. It has to either get plugged in or it's a black box that gets switched on when they need it to gain access to it. So at this layer, that's kind of what you're looking at from a typical SCADA system. They're normally manned 24/7 on the liquid side. On the gas side, A lot of times they'll have multiple controllers during the day. They may switch to 1 or 2 controllers at night because the activity for natural gas is a lot slower at night than it is during the day. And if you, I think we're going to take questions at the end.
Thank you.
If that's okay. So this is an eye test, and 49 CFR 192 is the regulations for gas, and 100 and 200 form the basis for design in a natural gas system. 49 CFR 195 100 is the basis for design for the liquid system. And so this determines a lot of what the operator has to do. So you'll see during the rest of the presentation, there's some connection between what the operator does, resiliency, and the law. Because ultimately, the operator is going to get judged against performance to the CFR. And that's done in California, it's done by the State Fire Marshal's Office. In different states, it's done by different jurisdictions. In most cases, it's done by the Office of Pipeline Safety. Okay? So this is deep within the Federal Register. I don't expect anybody to really kind of know where this is even at. There's a bulletin of regulatory proposal that gets published. There's hearings that take place, then the rules amended. And there's also regulatory appendices that are associated with this that determine the basis for design. And so you can ask questions around this. I didn't put the detail in on the gas side. I just picked one, 203, which is the instrument control, sampling pipes and stuff, because it would have been a similar eye test on the left-hand side as it is on the right. Now we move on into the field components, and I wanted to go through that eye test a little bit to kind of show you what the difference is now that we get into the field. A pump station, compressor station, there's not much difference from an I/O standpoint other than one has a compressor and is doing a compressible gas, the other one is doing a liquid. You have different sonic velocities for the liquid. Things happen a lot faster on a liquid station than they do on a gas station. But for the most part, you have pressure, temperature, flow. You have readings that you have to take. And the operator spends a lot of time working within those constraints. So I'm going to spend kind of the rest of the time on this chart here talking about how the law applies to the controlling of the SCADA system. When you look at the PLC typically receives operating instructions from the SCADA system. The SCADA system communicates on a regular basis with the PLC and tells it, hey, I need you to make a step change in your set point for the compressor or the pump. I need to open and close this valve. I need to do the following things. If the SCADA system goes away or is removed, the PLC actually continues to operate depending on its programming for a given amount of time. It will check periodically for a heartbeat with the host to make sure nothing has changed. If it's a critical station, it might do something different. It may go into a shutdown mode. It may operate differently. But you have to have good knowledge of the system to be able to understand how that particular station is going to behave throughout its life, or what happens if it loses communications with the host. The other thing that happens, people talk about, okay, can a hacker get into a SCADA system? Can the hacker make changes to the SCADA system to cause an explosion in a pipe? I would say anything's possible, but it's highly unlikely that there's enough knowledge in the SCADA system alone with all the other safety measures that are in place to create an explosion from occurring. So on the top, you see this little device here. So you have pressure relief valves that are set to vent the pressure in an overpressure situation. They're mechanical devices, typically not tied to any network or IT systems. They also, by law, they have to test them. on a regular basis. And PHMSA and the regulatory bodies actually check that these things have been tested on a regular basis. There's also flame arresters and pressure relief valves on a given interval that have to also be tested. So if you look at a scenario where somebody goes in and actually hacks into pipeline SCADA or control system, one, they have to have intimate knowledge of the operation. They've had to be listening for a while, or maybe a disgruntled employee that you got rid of. And you know, you hear these incidents about people doing these things to sewage treatment plant or water treatment plant. And in a lot of cases, they had intimate knowledge of what took place in those systems. You can buy that knowledge in other countries. You might be able to buy it in the US or Canada, I don't know. But I mean, in other countries, you know, you can probably acquire that knowledge, buy it, and use it to gain access. The other thing that occurs is in a lot of cases you have, you know, throughout the pipe, you have mainline block valves and small isolation valves. Some are manually operated, some are hydraulically operated, some are electrically operated. And the operator will use a variety of these throughout the pipe so that they can isolate what's going on. In a controlled environment, the PLC will, not the SCADA system, the PLC actually controls the I/O to that valve. The SCADA system sends instructions to the PLC on what to do. The PLC may not even have control of that actual valve. It may go to a local controller that the PLC is telling what to do, or it may go to an RTU from the SCADA system that tells the device what to do. In all those cases, if you sever the connection from the SCADA host, you still have some latency on operation. The other thing that happens if you were to take the SCADA system away, by law, the operator has to man the stations and has to have responsibility to man that station within a given period of time. So whether it's on top of Guadalupe Peak or out in middle of Louisiana swamp, if it's a station that has to be manned, they have to send people out and call people out to man that station while there's no visibility. And if there's a rupture or there's a leak, they also have to send people out. So there's a lot of safeguards that take place. There's also a section of the law around leak detection that the operators have to oblige by. So they have pressure readings that they do in, pressure out, pressure throughout the system. There's volume in, volume out. They do line balances. They have operator inspections on a regular basis. They have to have flyovers on a regular basis. There's a whole series of things. And then at the very high end, they have to have, you know, some lines are conducive to leak detection. And there's a whole standard in the law around implementing what they call CPM, computational pipeline monitoring. Those are for pipelines that tend to be a little newer, that have higher scan cycles, that's easier to get the data for. And those things take place. But if you look at all the mechanical devices that are in place, operating a pipeline has a certain set of criteria and a basis for design. But now if you're operating a pipeline within what's called HCAs, high consequence areas, typically that's a right-of-way for a federal highway, state highway, a school, a hospital. If you're within a certain number of feet, typically is about 1,000 feet from a river crossing, there's certain other things that you have to have in place. If you're crossing a river, you have to have pressure on both sides. You have to have a main block valve on both sides. There's things that take place. And you have to have notification, and you have to have public hearings with the local officials and the people. If any of you live near a pipeline right-of-way, once a year you get a notification telling you, hey, there's a crude oil pipe, there's a gas pipe within 1,000 feet of your home or 1,000 feet of the school. This is who owns it, this is the emergency number to call. And all those things are put in as safeguard to let people know what's going on with the systems that run through their neighborhood. as well as what the operator has done to ensure resiliency in operation. Do things happen? Things happen all the time. You know, I've been involved in an incident where a backhoe operator hit a natural gas pipeline that was buried 52 inches. When you go out, talk to the guy, there's a right-of-way marker on both sides of where the backhoe is. And you start talking to them, they're putting in a driveway. Okay, what are you doing digging 48 inches deep? Oh, by the way, you hit the pipe multiple times because you can see the dinks in the pipe, okay? And then you finally ruptured the pipe. So it's kind of, do things happen? Yes, things happen all the time. Bad things happen. Sometimes, you know, you look at some of the incidents that have occurred in California where you had a gas pipeline rupture, caught fire. You know, unfortunately, there was incidents. Billingham is probably the most notable incident. Gasoline pipeline ruptured, went in a lake, finally found an ignition source. But it's never just one incident that occurred. A lot of times there's things leading up to that incident that all of us had opportunities to see. The Billingham incident probably comes closest to having a cyber incident as part of it. The thought is, and there's some laws that changed after that the operator could not see what was happening because the screen was not updating because the CPU utilization was peaked out at 100%. And the memory utilization was peaked out because a change had been made to the SCADA system that may or may not have been tested before it was implemented. So there was a database error that caused the computer to go into a loop. And unfortunately, the technician that was there didn't have the admin passwords to be able to correct it. Very well documented. There's all sorts of documents and reports on it. It's been studied ad nauseum on that incident, a very unfortunate incident. But if you look at, there was people involved 10 years before that in the creation of that incident, where when the original pipeline was laid, there was no inspection. The inspection reports show dimples in the pipe that nobody checked. They thought that were within the parameters. The second inspection showed additional dimples in the pipe. When they did the water crossing for a public utility, they didn't send out inspectors to check to make sure that the line was in the correct place. So things like that, right? I mean, when you look at the history of that particular incident, any one of those things occurring correctly would have prevented that incident from occurring. And the very last one was where the line ruptured and the controller couldn't see what was happening. And, you know, somebody downstream smelled the gas fume, called in, and that's where it. And you look at other incidents. There was an incident in Walnut Creek about 10 years ago that the operator had laid out where the change was going to occur. They get out to do it. I call it the incident of the sacred tree. There was this big oak tree on the sidewalk that unfortunately it was approved for the right-of-way to go through, and the pipeline was going to go underneath that tree. When they get ready to go do it, they weren't allowed to do it, so they made a horseshoe bend around the tree instead of taking out the tree. Well, no one went back and documented that that had been put in. They go in, there's a road crew working on the road. They hit that little horseshoe in the bend, because theoretically, if a pipe's running, it's going to run straight, right? It's not going to take a little bend around a tree. It's going to keep going straight. And so things happen. In a lot of the incidents that I've been involved with, you know, majority the U.S. operators have the infrastructure with well-trained technicians that, you know, follow and comply with the laws. They keep track of changes and monitor their people to make sure they're well-trained. There have been incidents where, you know, in other countries where I've seen, you know, the guy shows up to work. I'll use Al as an example. Al shows up to work, likes listening to his music, plugs in his USB drive so he can listen to his music while he's working on the console. The thumb drive's infected. He just created an entry point into someone so that they can monitor what's going on, right? And to identify what took place in that particular incident doesn't happen right away, right? Because the hacker, whoever put that tool in Al's thumb drive, or he may have picked it up from a streaming site or wherever, he doesn't even know. All he wants to do is listen to his Nirvana music while he's at work because that's what he likes, right? So he's listening to his music. He doesn't know that he just created an upload or the ability for someone to monitor what's going on in the operation. So this goes on for a while till someone in the business side realizes there's an odd traffic going on between the DMZ and the external firewall that they're not used to, right? There's a little bit of traffic happening in the evenings, and then they figure it out. But on the other side, no one ever knew who this individual was or perpetrator was. They just knew kind of that this information was going out. And fortunately, it was able to get fixed before and shut off. But it takes a lot of remediation just so that, you know, that Nirvana music could play on the graveyard shift while, you know, you're working, and it happens. And you see that discipline not being as structured. I've seen cases where in some countries, you know, the economy's not as robust, where the controller will actually sell their codes to someone and they end up out on the market, and now someone has access to those codes. So if you look at kind of the field device, there's a couple of network layers occurring here. There's a I/O level, and there's an HMI and communications level that takes place. And then from there, it goes into an internal communication, typically. A lot of different modes of transporting the data back and forth that happens here. So I mean, when you look at that detail level, it's a whole host of devices that are here. You know, we're looking at all these things that can happen. Sensors, you got the whole control center. This is actually a control center. I use it a lot because it's kind of cool looking. And they're not all this big and impressive. A lot of them are, you know, fairly simple control rooms that are sitting in somebody's office. So with that, we have about 10 minutes to kind of go with you and discuss potential scenarios, right? So what you know about the architecture, you know, I look at it as there's two good potentials, right, for getting into a system. A disgruntled employee or an outsider. So the disgruntled employee is one that probably can occur to any one of us, not just in oil and gas transportation space. We fire people all the time. We get people released for cause reasons. But that person, when he walks out, you can terminate their access code. But they walk out with a lot of knowledge about the system. They walk out with, you know, as a friend of mine says, when that person walks out, he has seen you naked. He knows everything there is to know about you and more, because he was in the system. He knows what's going on. And, you know, they know that system. They know what the patches are. They know where the routers are. They may even know the IP addresses for the internal system by heart because they worked in it, right? They know what your telecommunications transport looks like. So there's things that disgruntled employee can do to get back at you a little quicker. So there's a lot of discipline around terminating access. I can tell you, when I was in a control room, we were not that good about it. We would let somebody go, and it'd be a month or two till an audit came along that we would probably terminate that access. If you go back 15 years ago, everybody in this room might have had the same username and password to get into the system, right? Because it was easy. Oh, by the way, that username and password was probably hard-coded somewhere in the system, so the vendor knew it as well. So if you wanted to get access to root, the vendor and every one of your employees knew that username and password because it was hard-coded into the system, it was built, and we all used the same one, so there was no identity between myself making a change or anyone else in this room or listening to making a change. Today, with Active Directory and different tools, that identity is there. If the employer and the user of the systems is using it as designed, that identity is there. So you can trace who did it, when they did it, what they did. In a lot of cases, the current SCADA systems will keep the past change, the current change, and what's going on. And because of some of the incidents that have occurred, now you have a rule in place that CPU utilization and memory utilization cannot exceed 50% per processor or memory slot. Kind of hard to manage in a Windows environment, so a lot of people tend to overbuild the systems so that, in a Windows environment, they look for 5 to 10% total utilization, because things will spike when you're doing an update or something like that. And it's not like in the old Unix days where you could say, oh, I want to partition so much processor or memory to this process and those kind of things. So you have that. The other thing that can happen, you can go in and change and corrupt a historian. You can make HMI changes. They're a little harder to do than I think the movies play them out to be. Because of the way things are occurring. But you're working on an operating system that if you make a change, the change is made in a test and development system, it has to get propagated into the production system, and typically it's somebody that has to know the system and has to have admin rights to the system. Can that happen? It can happen. If there's someone that is ingenious enough and trusted within the organization could probably do that. But the odds are they're going to have to get back into either a remote location or actual control center to do it. One of the things that most operators are pretty OCD about is not having network connections to the control system outside of the control environment. So you'll see that there's multiple layers of physical security to get into the control center in a lot of cases, where there's card key access to get into the operating space, there's card key access to get into the control center space, and in a lot of cases, even the president of the company doesn't have access to get into those spaces. So then I go on and to look at the outsider. The outsider is a little challenging dilemma because it has to be a well-funded, very patient individual, because they're going to have to figure out how to get access to the information about your system. They're going to have to get Al's thumb drive, infect Al's thumb drive, and be able to create and know what Al's habits are so that he can plug that in. And they need to know that he likes this kind of music and he plays this kind of music. So there's a lot of data gathering for an outsider to be able to, I'm hearing an echo. There's a lot of data gathering that has to occur before you go into it. And then you also have to be somewhat patient. If you look at some of these incidents that have occurred in the electric sector, these incidents didn't happen overnight. The perpetrator was very patient, very deliberate, and very methodical about what they went and did. We all say, well, that's not going to happen here, can't happen. Things can happen anywhere with the right amount of money, the right amount of patience. If someone is patient enough, they're going to find an employee within your organization that has unscrupulous needs, and they're going to tap into that. And it's possible that can happen. And employees are so trusting with email and spam that happens a lot. I mean, a lot of larger corporations have monthly spam emails that they send out to see who actually opens it, right? And they'll actually come down and talk to the individual. Hey, we sent out an email, you know, we've been training you not to open spam, right? You know, what was happening? So, because a lot of doors get opened by using email. A lot of companies have done away with Flash because of that reason. So you see there's things occurring in the industry that are kind of changing that. The other thing that the outsider can do is, you know, and there's been scenarios played out where an outsider can clone them, you know, and come in as, you know, put on the company uniform, borrow a badge, and come in as a physical. But at some point, the outsider has to gain access into the physical environment internally, either at a remote site or at the main control center, okay? And, you know, like we've been talking, just a tremendous amount of patience. But even if he does take control, there's so many layers of control to get to the actual valve out in the field to open and close it. And if he does overpressure, there's mechanical systems in place to keep it from occurring. You know, you talk about resiliency in our transportation. We have over 500,000 miles of pipe, either buried or visible across the US. We depend on that pipe to bring us everything from gasoline to crude oil to natural gas to our pipe, to our house. Because when I turn on my stove or my wife turns on the stove, I want to see a pretty blue flame that's at the right Wabi index when I go to put on my pot. And if I don't see that, there's something wrong, right? So that infrastructure has been around for a long time. It doesn't get updated very often because it's all regulated by rate, okay? So with that, we have about 2 minutes. We can start questions, as I promised. And the questions are up on the board, and you had a question.
Yeah, thank you so much. I try to understand the notion you said about the contingency and -2 and -3. Mm-hmm. The point is, like in a power system, usually we use the contingency N-1, and we will apply N-2 for some secure location. So what I'm trying to say is, if in the oil industry, 500,000 miles of buried pipe, we use a contingency N-2, N-3, it's going to be excessively, expensive, as infrastructure. So can you explain a little bit N-2, N-3 contingency to what?
So when I was using that N-2 or N-3, I was looking at, if you look at the network architecture of a client, right? So let's take an onion. The first layer of the onion, that's kind of your edge devices to the network, your IDS, your main router that connects the corporate LAN into your internet world. From there you come in, and then there's typically a series of routers in place to separate the pipeline control center to, in some cases I've seen it, 5 layers deep from where that edge device is. They make it very complicated. They make it to the point that it's so complicated on that SCADA system that non-essential services, Internet Explorer, those kind of things aren't even running on that HMI. And in some cases, that display console may not be in the data center. May be in a server rack somewhere connected by Fire to a dumb display node that in the control center is just a little black box with a USB plug for the mouse, a USB plug for the keyboard, and 3 SVGA cables for their monitors. And the reason for that is people have gotten pretty OCD about people like Al coming in to listen to Nirvana. Because, if you can eliminate that temptation, right, that And those things are not cheap. You know, when you're talking fiber connected devices, 1,000 feet from the control center, redundant fiber going into a black box just so that you can eliminate a display, yeah, those things aren't cheap. But they also want to eliminate, if there's a risk that occurred, they want to eliminate it. Because, you know, if you talk to anybody in the industry, at least in oil and gas, they don't want a front page newsworthy event on their watch, right? So they want to, those things can be typically justified. And they're not cheap. I mean, folks spend multi-millions of dollars to get their SCADA system installed and the physical security around it implemented.
Okay.
Yeah. Yes, sir.
Great. So thanks for the presentation. You answered one of my questions, which is why are they looking at email in the control room? And you said maybe that they're not.
So you're right. So they do look at email in the control room. If you go to most oil and gas operators, and you know, we were talking about one of the operators locally hosting you guys and one of your grad students, you will see that they have 3-4 monitors on the SCADA system, and over to the right they'll have an email or business system connected to it. Different LANs, different power source. Typically, that's how it runs. Even the IP telephony system is on a separate network, not associated with the control system. When you look at a typical control center, it is behind, typically, you have access to the building, you have access to the floor, which is limited to the people in that either maintenance or control center. Even the cabinets for the telecom and the network infrastructure secure. They really track the chases and where the cabling come in. And then you get into the control system itself. And in most cases, most of the operators I've seen or worked with, network plugs for that infrastructure is isolated just to that room or a separate area where they do configuration and testing.
My other question is starting from the field device. You mentioned disgruntled insider, outsider. What about an outsider who starts at a PLC? What can they do?
So if you start at the PLC, there's definitely opportunity to get into the protocol and mask what's going on with the protocol and messages back to the host. In a lot of cases, you're going through a polling engine that's limited to the request that it's getting from the host. That's not to say that some malicious traffic can be injected as part of that blob and sent back. You have to really understand and dissect the protocol to be able to integrate something. Is that possible? Probably. I've seen some really cool stuff that the research team has done, and I've seen at the National SCADA Testbed, where you're actually injecting infections into a protocol that are coming up. But then at that point, I still go back to that individual has to have really strong malicious intent and has to have the capability to, and the knowledge to perpetrate that incident at that site, right? Is it doable? Anything's doable. It's just, it takes a lot of effort to do. You have to be really up for the task of doing it. Are there people out there that can do it? Absolutely. There's people out there that can do it. Yes, ma'am.
Thank you. Thank you for the presentation. It seems like the cybersecurity for oil and gas is such a complex problem. You know, it can be intentional or unintentional attacks. You know, out of this overall, this complex problem of all aspects, if you can pick just one aspect or one problem, that is the most impactful, what would you pick?
I don't know if it's just cyber. I would say it's a cyber physical issue. Yeah. I think that's probably the most probable as a cyber physical combination incident to occur. So you're gaining access and causing an issue on the system. I think that's the most logical approach to take. I think to do a cyber incident without the physical aspect of it, in my mind, I'm struggling with that. I don't think without having knowledge of what's going on in the environment, it can be perpetrated at any. Can you do disruptions? Yeah, you can do disruption of the system. You can do denial of service attacks. You can do those kind of things. But at the end of the day, you know, the PLCs and the RTUs out in the field, yeah, they're 20 years old. They may not understand what you're asking of them to do anyways. Now, I've seen some of the really old legacy devices go totally stupid just with a port scan, right? Some of those devices, I would say, probably aren't out there anymore. So.
I try to add to that question. That was my second question. When we initiate a cyber attack, we should define the target, you know, on the physical infrastructure. During the presentation, you've been saying that there is a way to make explode a pipe. So my question was, if you can talk or you can't talk, it's up to you. What are the conditions we have to meet in a way to make explode the pipe?
So not in this environment.
Okay. That's okay, I understand.
I have a question. I have a question about the flow computer.
Okay.
In your block valves, basically, you have a flow computer, and I'm wondering, what does the flow computer controls? Does it control the mechanical devices? You also had on your slide that these flow computers are communicating wirelessly, radio or HART. I'm just wondering, are there certain concerns, depending on what the flow computer does, that there could be certain attacks?
So the flow computer is basically the first step in the cash register to the company. It takes the readings from end devices or orifice plates or pulses and translates that into an hourly, daily reading. Okay. Does it control the pipe? Yeah. In some places, they actually use to open and shut valves. On the natural gas side, the natural gas guys, if they're running, let's say, a cogen plant somewhere, there's an agreement with the cogen operator to either run on pressure control or flow control. So what does that mean? The operator of the turbine says, I want 235 psi plus or minus 15 pounds all the time. Or, so then the flow computer controls the pressure to make sure it's within the tolerance that's set in the contract. Otherwise, they're in violation of the contract. Or they're on flow control. So I want 150 MCF a day. It'll actually make sure that the flow rate that it's pushing through will end up at that flow rate. Okay? The flow computer basically takes that reading and actually translates that reading, and it goes into a measurement system that actually ends up being the cash register for the company at the end of the day. That's what pays the bills for the operator. So that flow at that station is getting billed to somebody based on a tariff to operate that cogen or that smelting plant or that aluminum processing facility or whatever it happens to be, based on. So, and there's a lot of factors that go into what the nominations are, what the volume they ask for, there's tolerances in there. But the flow computer plays an integral part in the billing and the economics for that company.
So that actually then means that that flow computer can have multiple interfaces. It might communicate with the control center. It communicates with the valves to actually control the flow. So it seems to have a multilateral
So the flow computer is kind of a unique animal because the flow computer can actually have more interfaces than that. Because the flow computer can actually connect to the host facility at different memory registers so that the host facility can see the same thing that the billing entity is going to see. So they take the register readings from the flow computer that company A, the host providing the product, is seeing, and they clone it to a different set of memory registers that entity at that site can actually get as well. That way they can see, it's kind of like on the electric side, you'll have dual metering, or you have those kind of components taking place. It's the same thing. It's happening within that one flow computer. There's also companies that'll put in their own because company A uses this type of flow computer, company B wants to use this other type. And, you just got to make sure they sync up and the readings are the same. But yeah, the flow computer can have actually what we call third-party connections, which is the host facility. Yeah, good question. I don't see anything up there, so I'm assuming, yes, sir.
Do these companies have in place like protocols in case the system is successfully attacked to fix it and wipe out any infiltrating like viruses or programs or hackers from like the outside that have already successfully penetrated the system?
So most companies do have a protocol, and they actually, they exercise, they do desktops basically against them, and they run through kind of what if scenarios they would do. A lot of it falls on the vendors getting certified patches sent out quickly, because in a lot of cases, the owner of the SCADA system or the technology that's being deployed can't really install a patch unless their vendor vets it first, because a lot of cases, the patches that get sent out may not be relevant or may break other things. So the first step is getting the system patched. The second step is understanding, what the IDSs say, what the system is doing, what happens if you get an alert, what are you going to do, how are you going to remediate, right? And you're talking systems that are redundant and replicated in real time, so you have a whole series of things that you got to do to remediate that. Yeah, most of them have pretty thorough plans for that. And a lot of times they work with their corporate IT departments to make that happen. Yes, sir.
Is that because it's heavily regulated?
I think so. And, it goes back to the fact that, the philosophy is I don't want an incident on my shift, right? And the last thing you want is an incident on your shift. Yeah, it's heavily regulated, but if you look back, 15 years ago, I don't think it was that way. People weren't that interested in, hey, it's never happened, it's probably not going to happen. My system's so obscure anyways that, and I think, you look at the different entities that covered the industry from a lobbying and representation standpoint, they're pretty active with their user community around cybersecurity. Most of them have a cybersecurity person on their staff that works with the different operators that are members. They have cybersecurity standards, cybersecurity plans. They have roadmaps for their clients to use. Some even have, procurement language that they should be using. It's changed a lot since the days where you had embedded user ID passwords to get access to root. Now, that's not to say that there's somebody out there that's still doing that. There's over 700 operators in just the U.S. alone. There's probably some company out there that may still have a 1990 vintage system that is doing that. Okay.
Okay, well, we are out of time. Thank you so much. Appreciate coming.
No problem.